So for this video about exponential growth and decay, you're going to make sure you want to have a calculator that can be risen to a power and that can take the natural log of things. So either a program or an internet or a TI or a whatever, Casio calculator, you're going to need something to be able to exponentiate and raise to a power. Okay, because all of these problems require us to use this formula of the amount equals the principal times the number E, 2.71828, the natural number, raised to the R times T power. Okay, so future amount, initial amount is your P, your rate of growth or decay. If it's negative, it's going to be a decay. And time will be given to you in the problem. So make sure you are being consistent. If it's given to you as a daily growth rate, then you have in days is your units for the problem. So number one, let's jump right in here. Under ideal conditions, we have bacterium growing at a rate of 16% each day. That is your rate. 0.16 is your growth rate, right? Because we always change our percentage into a decimal. Initially, there are 25 organisms, so that is our p-value. That's a not very good looking p. There's a better looking p. That's your initial amount. So write an equation. Well, that's pretty okay to do. The amount in the future equals our 25 to begin with times E raised to the 0.16 times our variable t, which in this case is going to be days. Okay, so we write our formula with the initial amount, our rate as a decimal, and our variable time. And now we answer the question, how many bacteria will there be in 4 days? So now that we have our t value, we're going to solve, or rather just strictly plug this equation in, 0.16 times 4, into our calculator, however you're going to do it. And that's, you're going to get this answer. 47.4, right? But we don't want to have 0.4 of a bacterium, right? So we have a total of 47 organisms, or 47 bacteria, or 47. Okay, we're going to round down to the nearest whole number when it comes to living organisms. Okay, even if I'm missing an arm, that doesn't mean I'm 3/4 of a person. I am still a whole person, no matter how many limbs I'm missing. That's just mean. Okay, and then number 3, when will there be 200 bacteria? So that is your A value, and we're trying to solve this equation for T. So we're going to set up our equation as 200 equals our original 25 E to the 0.16 times T. Okay, so these are pretty classic problems for exponential growth and decay, and there are 3 steps that we're going to use to solve them. The first thing we're going to do is divide both sides by your initial population. So divide both sides by 25. Okay, we want to get rid of our variable so we can solve for t in our exponent. So I believe 200 divided by 25 is 8 equals e to the 0.16 times t. So now I want to get rid of my base of my exponential, which is e. So I need to take the log with the same base. In this case, that's called the natural log, or log base e. So I natural log both sides, and that eliminates my base of my exponential there. Okay, so now I have something that looks like the natural log of 8, which is some fabulous number, but I haven't touched my calculator yet, so I don't know what that is, equals 0.16 times t. So we have divided both sides by 25. We've natural logged both sides to get rid of our base, and now we're going to divide it one last time by our coefficient of t. Okay, now I'm going to put this into my calculator. The natural log of 8 divided by 0.16 comes out to be 12.999, which is about 13, and our units are days. So after 13 days, there will be 200 bacteria in this petri dish. Okay, our exponential growth. So we're assuming that the rates or the conditions stay the same, so that your bacteria can continue to grow exponentially with uninhibited. Nothing is trying to kill them off. Okay? So that's how we attack all of these problems. A standard sedan, so a car, right, a four-door car, a family vehicle, was purchased for $15,000 in 2015. In 2020, it is valued at $8,000. So that is after how many years? 2015 to 2020 is 5 years. So what is the rate of decay, right? It's not worth as much as it used to be, so we have a decay function. So you should expect to have a negative rate. So our equation looks like 8,000, that's our current amount, that's the current value, equals 15,000, your initial cost, times e to the r times 5. Remember, it's 5 years from 2015 to 2020. So our t value is 5. Okay, so do these 3 steps. Divide both sides and by 1,500. Natural log both sides, and then divide again by your rate or by your time and see what you get. So that's what I got. When I divided both sides by 1,500, took the natural log of that decimal, and then divided that by 5, I got a rate of negative 0.1257 or 12.6%. Okay, negative 12.6%. So now I'm going to use that rate in order to figure out what the value of the sedan will be in 2025. So if I take my initial 2015 to 2025, that is a 10-year cycle. Okay, so if I'm going to find the amount, I always go back to my original value, 1,500, times e to my negative 0.1257. Okay, I go back to this number right here that I calculated, okay, before I change it back into a percentage, to 4 decimal places. Okay, keep 4 decimal places accuracy whenever you're doing this type of a problem. Times my time, which is 10 years. Okay, all this goes into my calculator, so plug it all into your calculator and you should get this answer. $4,267.59 would be the approximate value of that sedan in 2025, okay, if nothing else changed. So then our last question here says, when will it be worth $2,000? So this is our A amount, right? When is our sedan going to be worth $2,000? So 2,000 equals our original equation, 1,500 e to the negative 0.1257 times t once again, our new variable t. So we're going to do those 3 same steps. We're going to divide both sides by 1,500, natural log both sides, and then divide again by our rate. Okay, so take a second to do that, pause the video, and then check the answer. So about 16 years after 2015, so if it asked you for the year, that would be the year 2031, because that's 16 years after 2015. Okay, so both answers would be acceptable. You either write 16 years is the time, or you could write in the year 2031, the car will be worth $2,000. Okay, if everything goes well and it's well made anyway. So our last example here about fruit flies, those pesky little fruit flies. In 2 days, the colony grew from 12 to 70. 12 flies became 70 flies. So what is the rate of growth? Okay, so our 70 is your A value and 12 is your P, right? We initially had 12. So we can set up this equation, 70 equals 12e to the r times. How long did it take it to grow from 12 to 70? 2 days. 2 days. So 12 to 70 in 2 days. Our 3 steps are always divide, natural log, and divide. Okay, so do that and come back and check, see if you got it right. The rate I got was 0.8818, which is 88% growth. That is some fast-growing fruit flies, 88%. So part B, how many flies will there be in 2 weeks? 2 weeks' time. So that is our A question. The amount started with 12. Our rate is 0.8818 and 2 weeks. Okay, don't plug in 2 because our growth was first given to us in days. So we're going to change our 2 weeks into 14 days because our rate was a daily growth rate of 0.88% per day. Remember, this is given to us in days. So when I plug that into my calculator, I get a stupendous number of gross fruit flies. So 2.75 million fruit flies. Let me check that. Hang on, I'll be right back. Yep, that's right. 2.758 million. 2.758 million fruit flies. Holy bejeebers, that's a lot of fruit flies. So the last question, when will there be 1,000? So that's 1,000 here equals 12e to the 0.8818 times t. Okay, we're trying to solve for t once again. So our 3 steps are divide, natural log, and divide. So divide both sides by 12. That's 83 and change equals e to the 0.8818t. Now we can take the natural log of both sides to get rid of our base e. And then we can divide both sides by 0.8818. So I am kind of jumping around here, 0.8818. Okay, put all this into the calculator, the natural log of that digit divided by 0.8818. After 3.9 was the answer, and our units are in days. So after 3.9 days, there would be 1,000 of these pesky little fruit flies flying around. Okay, so exponential growth, there are 3 steps. We divide both sides, we natural log both sides, and then we divide both sides again anytime you're finding the rates or the time. Just kidding. My class said it's actually 5 days, 5.0157. So 5 days. I multiplied in my calculator rather than dividing. Lo siento mucho. Okay, now we're done.